This video series summarizes the workflow for implementing 3D scanning for the damage assessment of bridges with a focus on the corrosion assessment of steel beams. This training was developed under research project SPR 2310, funded by the Connecticut Department of Transportation. The PIs on the project were Arash Zaghi and Alexandra Hain from the University of Connecticut.
So in this video, we're going to go over what to do if you had problems with the initial alignment. We're going to start again with running that fine registration on each of the scans using both the geometry and texture. And this helps us filter everything out before we get started with our processing. And this is sped up so the process doesn't go quite that quickly. And then after we've run fine registration on each, we're going to actually do the global registration on the individual scans rather than doing it on all of the scans together. This is not the normal approach, but for this method, it allows us to really finalize those scans before we move to alignment. So to make sure you're only running on one at a time, you're going to highlight that, turn the eyeball on so that scan is visible, and then go ahead and run global registration for each of the three. Keep in mind that this can take some time and it doesn't require any user input, so just kind of plan accordingly when you're doing your processing. You may want to set aside some time when you have other tasks, do each of these components, let them run, and then start the more intensive process where you have to have user input. Once the global registration process is completed for each of the scans, you're going to see we have those error numbers again. And what's different this time is we're going to set a lower threshold for the error that we're willing to accept. In some areas, if there's a larger error and it's one of those points that's being used as a tie point for the scans to really bring it together, we could have some issues. So in this process, you need to find the correct level of error that works with you. We want to get to the smallest level that doesn't delete information. So you're going to start sorting those errors, deleting the higher errors. And then once you delete those, you're going to go back to your initial scan, look at it, and see if any of the data you need has been removed. If it has, then you will undo and keep those scans. And if not, you'll keep lowering your error threshold. Not only does this remove the lower quality data, but it also gives us less data in general to work with, which kind of lightens up our scan and improves our processes. So you're going to go ahead and do that for each of the scans. This is a really important step because it allows us to filter out all of the low quality data we collected and just keep the frames that are the best. So we're only going to be working with the overall frames that have the lowest amount of error. This makes it less likely that we'll have those problems with alignment because our error can kind of stack up on top of each other. So the only times we want to keep those higher error scans are if it's the only scan we have in that area. So once we've deleted our frames, we just want to zoom around, take a look, make sure everything looks okay. And now you can see there that the target bars are off, and that's what we're going to take care of in our next step, the alignment. So for the alignment, we're going to move on to the left tab, select Align. And what we're doing here is you can see on the list of scans, one is blue and the other two are tealish green. And what those are is saying the blue one, we're marking that as registered. So we're saying that is our base scan. And the two green ones are the ones we're going to match to that. So just keep in mind that blue one is the one that's locked in place. So the first thing we want to do is match the two scans on the same side. So for that, I set scan 1.1 to be unregistered, and I'm going to work with the two scans on the other side first. Unless you're using auto alignment, you can't do all the scans at the same time. So you see there's a lot of overlapping features. Those were matched without a problem. So now those are both marked as registered. That's why we have them both as blue. So then we need to bring in our other one and align that. I'm going to take a look around, make sure there are no obvious alignment issues, and then we'll bring that other scan in. You can try the same process where you enable that texture align and try and align the surfaces. However, since it's the scans of the separate sides, all we really have in common is that bottom flange, this process can often fail. which means we need to move forward into the manual alignment. And this is where we select common points on the two scans. And those points are normally areas that have a lot in common, whether this is the center of our X, points on our target bar, anything where we have some really defining features that we know we can match. And this is where our target bars really come in handy. Selecting points here is a little bit easier than when taking measurements. It does a better job. And you should try and select a minimum of 3 points at kind of different areas along in the two scans, but you can select multiple. There isn't a limit on the number of these. It can also be very helpful to change the color so you can see the differences in the two scans. So for that, go into View, Color, and change it to Scan Color. This can help make it more clear what you're matching. Using the different visualization tools are very helpful when we're trying to see the model from a bunch of different angles. So colors, you can change these colors as well to make them anything you want to make sure there's a clear difference. One of the nice things about this process too is you can add additional points as you go. So if you need to make finer adjustments, you can do an initial align of the markers and then add more points and continually align. And we're also able to go in and then remove some of those points. So you can go in, bring the alignment a little bit closer, then remove all of your points and start again. So you have some options for this process. And then once we've added our points at multiple locations along the beam, we can go ahead and hit align markers. You then see the beam move in that direction. Now you can zoom in to your areas such as the web in front of the stiffener, those areas on the target bar, and do a check to make sure everything's lining up properly. If not, that's when you can go ahead and add more markers to do further adjustments. This is another one of those times you may want to go in and delete some of the markers. If you find you're getting a bunch in one area, you may want to kind of delete them, start over, and make sure you have a more even distribution. So go back, add any additional markers as needed, and then once you're happy with the overall alignment, switch back to texture in your color tab. And this gives us an opportunity to check our target bar and the other markers we've drawn on the beam to make sure everything seems like it's in alignment. If everything looks good, just go ahead and hit apply to save this orientation. Once you hit apply, this will bring you back to your main screen where you can see all of the scans aligned. And this is where our process can vary a little from the traditional approach. First, as always, you want to go ahead and make copies of these scans now that they are well aligned. Once you make those copies, you want to go ahead and unload them so it's not taking up room, and then trim your scan. So we're only working with the beam information we're most interested in. And we can focus on any different area here. It's often nice if we want to kind of do a first run where we erase information, but then you want to hold off and say, I can erase more after fusion. But whatever you're really interested in for that final product, make sure that you do that in your first round before you fuse. Once we've deleted all the extra parts of the scan, we can move on to fusion. And we're going to choose fast fusion for this purpose just because we've had some problems with the alignment in the past. We want to do a check first. You see this window that pops up, and it's basically asking us if we want to run fusion without running global registration. Normally, that's not something we want to do, but for this process, since we've already run global registration on the individual frames and done all the manual alignment, we want to select Run Fusion. And after this process is completed, we have our final fused model. Once we have our final fused model, we need to check our measurements again to make sure the alignment problem was solved. This time we're going to do it differently. Rather than doing parallel to an axis, doing not constrained. So you go ahead and select 3 points, and that will generate a plane. You can then slide the plane the same way as if you aligned it on an axis. So you want to make sure your whole web section is selected. Go ahead and create that section, and then again, we're going to duplicate it along the length. And remember, when we're making those sections along the length, you're not always exactly sure what you want that spacing to be, but you can go in, change the number of planes, the number of spacings. This is our first check. If you're trying to do a more detailed analysis, if you really want to see in 6 inches how much your level of corrosion is changing, you might want to have smaller spacing. Once we have our sections, we're going to go ahead and take our linear measurements. So go in, select the scan, and show all measurements. This is the same process that we went over initially. Taking these measurements can be a bit challenging, but what we really want to make sure we do is rotate the beam. So even at the front, if we feel like we're clicking on the same point, we want to do one face, then turn the beam around, do the other face, and remember to always check show all measurements if we want to be able to see those section cuts. If you don't do save measurements and you just start trying to take another measurements, everything will be connected, and then you just have kind of a jumble of lines with measurements pointing every which direction. So make sure that you're trying to keep it focused on the measurements you're taking, and if you need to move a point to fix it, go ahead and do that. And then once we have all our measurements, I find it helpful to kind of go in between the web so we can see each point more easily, and then just readjust to make sure that we're getting a measurement that's perpendicular to the plates. So you have to go in and do this each for individual measurements. So change the 2 points by editing and then apply, and then that'll save the final positions. And then once we've double checked all our measurements, you just want to zoom out, make sure everything looks like it's lined up correctly, and make sure that all our measurements are reasonable. Once again, this is only doing a check along the length of the beam. You also want to repeat this for the intact portions along the height. If we're still having challenges with our alignment, there is another method. It starts the same way by doing the fusion and global registration for each of the individual scans, and then going through and deleting those scans with high error, just like in the previous video. Just another reminder how important this step is. We really want to make our file that little bit easier to work with. So if we can remove the scans that have higher error, that are really doing nothing except causing some problems, and bringing that error level down to the lowest possible, that's one of the best things that will help us in having a high quality scan overall. Once we've deleted all those scans, we can move into editing out our extra geometry. You can go through, delete all the extra information that we're not going to use for our alignment. Once that is complete, we can then move into our alignment. And what we're going to do here is we're going to bring in an object, such as a rectangle, that has the same thickness as the web. This essentially ensures that when we're lining up our 2 faces along the intact portions of the web, that we'll have a known web thickness. So this is showing the plate that we've brought in. We're going to go ahead and align that with our other faces of the beam. You can see that both 1.2 and 1.3 are marked as registered. Those are done first, similar to the previous video, as these scans are on the same face. So we want to make sure those are set before we do our alignment. So this picking points is the same way done in the previous video, and what you want to do is just get it so that face of the plate is lining up with the face of your beam. So for the plate, I brought in an OBJ file that I generated in SketchUp, but this can be a variety of file types generated in a variety of platforms. So really whatever works best for you to bring in the 3D model, you can use that. So in this, I took the approach of taking the different points, matching them first in order to bring the plate that little bit closer. But you can also do this manually. You can drag this over if you'd like to do that before you're using the points. So it's really whatever works best for you. Same situation here. Once you have those points in a general alignment, you can also delete those and start again, essentially from scratch, with less of those points being tied to the components. Once we're happy with that face, we can go ahead and mark that scan as registered, and then we can bring in the other face of the beam. In here, we want to make sure we're using points on both the scans as well as the plate for our alignment. So we want to make sure that we're still getting matching at the front of the web and along that target bar. We're just adding additional points along the intact portion of the web to match to that plate. And we need to remember that we're not doing any other alignment after this manual alignment. We've already run global registration on the individual frames, and that's normally our other opportunity to do an alignment of sorts by registering all those scans together. Since we've already done this, how the alignment looks in these frames is going to be our final alignment before fusion. So make sure you take your time and really due diligence when you're selecting these points, checking the target bar and the other areas of overlap, front of the web, making sure that our alignment looks consistent along the length, along the width, underneath, and on our target bars, so we're not having any problems before fusion again, because otherwise we're going to have to come back and do this process again. And once we're happy with the overall version, we can apply these changes and then move on to our fusion step. So for fusion, we're going to go under Tools, and we're going to do a sharp fusion, and we're going to choose to close holes manually. Once you're done, you're going to get this option. If you want to close holes, this is where you have the option to select them and then apply. And once that process is done, we can go ahead and take our measurements. So we start with the section cut and then do our individual linear measurements, the same way that was done in the past videos. So we're going to start by making that first initial plane and then copying this plane along the length. So we have those multiple reference measurements that we can pick our points on. This makes it very helpful. Of course, if you're doing an initial check, you can just go in and select points. You can skip this sections tool, but I find it helpful as a guide. So go in, you make those sections, and then remember you're picking the points on either side of the web. Picking points is one of the most frustrating processes in this step. It's interesting to me that it's easier in the alignment to pick points than it is in here, but you want to go over and really make sure you're picking the correct points. This is what we're using to make our judgments on the beam thickness, so we need to be absolutely certain that we are picking the right points. So go around, make sure you're taking it on one side and then rotating the beam around to get the other side, and you can always go inside the beam if you need to make slight adjustments. So when you go back in to double check your measurements, just make sure this is within the range you're looking for. If not, you may need to go back and make some slight changes in your alignment. Once you have a consistent setting, this is when we can go back and apply our texture, select all the scans, hit yes to apply even though it's a time-consuming process, then let it sit. Change your color back to texture when the process is done, and then adjust your markers so you get the picture you're looking for in terms of color and saturation. And after that, your model is complete. You can always go back in and trim more before export.